Hello everybody and welcome to your 37th and 38th chapter in your Java EE7 tutorial series. In this tutorial, we'll be talking about the introduction into the Java Persistence API. Now, I want you to close your eyes and imagine the good old days of programming. Times where you only need to worry about code like if statements, loops, and arrays. You knew that variables are spaces allocated in your computer to hold information. At this simple time, variables were the only way to hold data. Variables worked fine until you realized that you would need to store data even after the application stopped running. There are many solutions for this problem, like writing your data into a text file, but the safest, most secure, and overall best way to store your data is into a database. Now, there are a few ways to store data into a database, but the way I'll show you right now, which is one of the best ones honestly, is using the Java Persistence API. The Java Persistence API makes it easy for Java developers to work with relation databases like Oracle DB, MySQL, PostgreSQL, and more. JPA allows the reading, writing, and managing of data in databases without ever leaving the comfort of Java. So, Java Persistence API consists of four areas. First, the Java Persistence API, the query language, the Java Persistence Criteria API, or Criteria API for short, and the object/relational mapping metadata. So first of all, entities. An entity is a lightweight persistence domain object. Think of an entity as a representation of a table in a relational database, with an entity instance as a corresponding row of that table. Now, each entity has a unique object identifier. A customer entity, for example, might be identified by a customer number. The unique identifier or primary key enables clients to locate a particular entity instance. Every entity must have a primary key. An entity must either have a simple or a composite primary key, which is a primary key with multiple attributes like height, age, and name. Inside our entities, there are relationships. The first relationship you will see is a one-to-one relationship, where each entity instance is related to a single instance of another entity. For example, if we have a group of storage bins that each contain a single widget, this storage bin and widget would have a one-to-one relationship. Next, there's the one-to-many relationship. An entity instance can be related to multiple instances of the other entities. And for example, a sales order can have multiple line items. In the order application customer order, the customer order would have one-to-many relationships with line items. And this can be true in the other way around. Multiple instances of an entity can be related to a single instance of another entity. This multiplicity is the opposite of the one-to-many relationship. In the example just mentioned, right, the relationship to customer order from the perspective of line item is many to one. Finally, there's the many-to-many relationship. The entity instances can be related to multiple instances of each other. For example, each college course has many students, and every student may take several courses. Therefore, in an enrollment application, course and student would have a many-to-many relationship. Now, you remember inheritance and polymorphism from regular Java? Yeah, entity classes can do that too, with both its own entity classes and non-entity classes. Entity classes can also be abstract or concrete, which means non-abstract. Okay, so entities are great and all, but what if we have to create, update, and destroy them? These are what entity managers are for. Entities are managed by the entity manager. Each entity manager instance is associated with the persistence context, a set of managed entity instances that exist in a particular data store. What that means is every single one of these guys are basically like entity managers for all these entities. Now, getting into querying entities. Entities can be queried with the two methods, the Java Persistence Query Language, or JPQL, which is a simple string-based language similar to SQL used to query entities and their relationships. We'll see more of the Java Persistence Query Language in Chapter 39. And then there's the Criteria API, which is used to create type-safe queries using Java programming language APIs to query for entities and their relationships. We'll be seeing more of this guy in chapter 40. Now, there are advantages and disadvantages to both. JPQL has a few advantages, which, first of all, just a few lines long, JPQL queries are typically more concise and more readable than criteria queries. Developers familiar with SQL will find it easy to learn the syntax of JPQL, and JPQL has named queries which can be defined in the entity class using a Java programming language annotation or in the application's deployment descriptor. Now, the disadvantage of JPQL is that the queries are not type safe and require a cast when retrieving the query result from the entity manager. This means that typecasting errors may not be caught at compile time. Now, into Criteria API. Criteria queries allow you to define a query in the business tier of the application. Although this is also possible using JPQL, dynamic queries, criteria queries provide better performance. Criteria queries are also type-safe and therefore do not require casting as JPQL queries do. And the Criteria API is just another Java programming language API and doesn't require developers to learn the syntax of another query language like SQL. Now, the disadvantage is that criteria queries are typically more verbose than JPQL queries and require the developer to create several objects and perform operations on those objects before submitting the query to the entity manager. Now, when developing an application that accepts data from users, it can be a pain in the butt to add data in manually yourself, simply to test your own application. Fortunately, the persistence provider can be configured to automatically create the database tables, load data into those tables, and then remove the tables if you need, using standard properties in the application's deployment descriptor. We'll be seeing examples of these later on. So look at that, there's an example. So now let's take a look into our order example. Inside our NetBeans, let's go ahead, right click and click open project. What you want to do is you want to navigate to your persistence inside your examples batch and go ahead, click persistence and double click order. So the order application is a simple inventory and ordering application for maintaining a catalog of parts and placing an itemized order of those parts. So first of all, the order application has all the types of relationships that we've talked about, like the one-to-one, the many-to-one, and so on. If we take a look into our part and line item stuff, so if we go ahead, go into your source packages, it should be an entity. Let's see, part. All right, so inside the part.java, you will see, first of all, if you scroll all the way down, you will find a many-to-one annotation, which tells that these parts right here are connected to one thing, which is our part number. If we go to our line item.java, if we scroll all the way down once again, you will see a many-to-one as well over here. This many-to-one tells us that the vendor parts have a many-to-one relationship with the order, like the kind of order that you pick. Next, the order application uses several types of primary keys. So the single valued primary keys, generated primary keys, and the compound primary keys, which can be found in the vendor.java. Once again, if you want to go into any of these, go into your Java EE tutorial.order.entity and then go into these classes over here. If we scroll up, we will find that the primary keys are given right over here. Here in this table generator. The primary key here is the generation key, and then another primary key would be considered as the part ID. Alright, so next we have our stateful session bean, which is our request bean.java. This contains all the business logic and manages the entities of order. This then you can see inside here. You can see that first of all, it goes ahead, it creates parts, as you can see in this method. It also gets all the parts, any build material, and creates any vendors that that's asked or needed. Okay, so now that you got that, let's go ahead and make sure that your Glassfish server is running. So in my case, it is. And we can go ahead and click build. Once it's built, let's go into our order and run it. Now this will deploy this right here. So you can see that, first of all, there's two order IDs which are automatically generated for you. There's the shipment info, the status, the last updated, and the discount, and actions. Let's say if you want to delete this guy, you can go ahead and delete him, and he'll be gone. If you want to create your own order ID, you can go ahead and put in any number, put in your shipment info, put in any status, let's say complete, and let's give this guy the biggest discount. Let's go ahead and click submit, and you can see now that your order ID is now submitted into this table over here. You can then go ahead and search for some vendors. You can try that out, and you can find any vendors that will support these shipment infos. You can also go ahead and click any of the order IDs to see any of them in full detail. Let's say if we go into the one that we just created, you can see that you have all these parts and these part numbers, and then you can go ahead and add the order to this line item for order 2222, and you can go ahead and add anything you want, and it will be added to that. And we can go back to the orders, and you can see that if we go back to the order ID, it's changed up to this table. And that's it. That's all there is about the order example. Now that we're done with that, let's take a look into our roster example. Now that we're back in our NetBeans, let's go ahead and clean and close this project. Go ahead and open a project of the next one, our roster example. So the roster example maintains the team rosters for players in recreational sport leagues. Functionally, roster is similar to the order application with three new features that order does not have: many-to-many relationships, entity inheritance, and automatic table creation at deployment time. So a recreational sports system has the following relationships. First of all, a player can be on many teams. A team can have many players. A team is in exactly one league, and a league has many teams. In roster, this system is reflected by the following relationships between the player, team, and league entities. First, there's a many-to-many relationship between this player and team, which you can see in your team.java and player.java. If we go into our roster EJB, go into source packages and entity, you will find that we have team, player, and league. Inside our team.java, if we double click that, you can scroll all the way down and you will find that there is a many-to-many relationship between the teams and the players, since there's multiple teams and there's multiple players. If we go to our player.java, it's completely the opposite. It's a many-to-many relationship, but instead of applying all those stuff in your team.java, as you can see over here, like joining the columns and everything, all it's saying is it's being mapped by players. And it's saying that whatever is inside our team, just literally like copy it down. And that's what you got for your players. All right, so then there's also a many-to-one relationship between the team and the league. If we go to our league.java, if we scroll down, it's a one-to-many relationship cascaded by all and mapped by the league. If we go back to our team.java, once again, we have a many-to-many relationship, and league.java has a one-to-many relationship. Okay, so there is an entity inheritance in the roster application. The league entity in roster is an abstract entity. If we go into league, you can see that it's an abstract class with two concrete subclasses: the summer league, which you can see over here, and the winter league, which you can see over here. These leagues check if the sport belongs in their league. Finally, or actually, let's take a look into these. So the summer league, you can see that it's actually checking if the sport is swimming, soccer, basketball, or baseball. If not, it will say that this sport is not a summer sport. And the same goes with winter league. If it's not hockey, skiing, or snowboarding, this sport will not be a winter sport. Okay, so next there are criteria queries in the roster application. Many of the business methods in a request bean define criteria queries. One business method, get players by position, returns a list of players who play a particular position on a team. If we scroll, oh, that's a lot. If we scroll to, or if we find by doing Control F, and we find get players by, we can find our method which says get player by position, which returns a list, as you can see over here, which returns a list, and it tells it where they play, like the particular position that they play in, by using your criteria API that we talked about before. Okay, so at deployment time, Glassfish server will automatically drop and create database tables used by roster as defined in the persistence.xhtml. So you can go to this persistence.xhtml by going into your other sources, main resources, meta-inf, and persistence.xhtml or XML. You can go ahead and click source, and you will see that there's this guy over here which has the value of drop and create, which basically drops all the tables and creates all the tables as shown as you want. Okay, so now that you got that, let's go ahead, start your Glassfish server once again. Go ahead and click build. And once your build is successful, let's open this guy up, and you will find, if we scroll all the way up, you will find that we have a list of all the players in the teams and the leagues. We can then separate them by defenders, league of players, and any details of the team. And you can see the rest of the details over here below. And that is how the roster example works. Once we're done with our roster example, let's take a look into our final example, address book example. Once you're done with that, let's go into our roster, clean this guy, and let's close him. Oh, actually, let's go ahead and close all these. Go ahead and click close. Okay, so let's open our project, and our final one will be our address book example. The address book example application is a simple web application that stores contact data. All right, so first of all, if we go into our contact.java, if we go into source packages and we go into our entity and we double click contact.java, we will find a few things over here. So first of all, we will see bean validation constraints. As you can see, these annotations called @null tell that the user cannot leave these stuff blank. They can't like keep their first name blank and fill in their last name. They have to fill in every single part of this form. Next, there's the @pattern, which tells us that it's like a basic kind of validation, which checks if the email has like a first part, last part, and the @annotation, and then you have like gmail.com, something like that. Or else it'll give like an invalid email, invalid phone number, and invalid phone number if we put in something wrong. Like, for example, if our phone number is not numbers and like letters, then like it will say it's an invalid phone number. And then there's the @past annotation over here above our date birthday. This checks if the birthday is in the past, since obviously your birthday can be in the future, right? All right, so now let's take a look at specifying error messages for constraints in address book. So once again, in the contact.java, we saw that our error messages, invalid email and invalid phone number, these take their string values from the resource bundle validation messages.properties. If we go into order sources and go into meta-inf and double click persistence, not persistent, where are you? Default package, validation messages.properties. Over here, you will see that there's an invalid.email, right? Which tells us, gives us a string not a valid email address, and invalid phone number, which tells us it's not a valid phone number. So you might ask, Viprav, why are you doing this? Why are you like separating, like your error messages? This is because let's say if like a future developer comes in and they want to add like another locale, like let's say a local resource bundle like in Spanish, this will help immensely because like you can create another property tag and you can create one for Spanish speaking locales. Okay, so next let's take a look into validating contact input from a JSF application. if we go into our create.xhtml, which you can find over here in our web pages, your contact, and double click in create.xhtml, you will find that all this is doing is, the address book application uses a JSF web front end to allow users to enter contacts. While JSF has a form input validation mechanism using tags in Facelet's XHTML files, which you saw before in my previous tutorials, the address book example does not use any of these validation tags. Bean validation constraints in JSF manage beans, in this case in the contact entity, automatically trigger validation when the forms are submitted. Yeah. So you can see that the first name and last name are bound to attributes in the contact entity instance selected in the contact controller stateless session bean. And each H input text tag has an associated H message tag, which you can see over here, our H message tag. So once again, it's telling you that each input text has a first name, it's getting the value, and if the message is wrong, then it'll give out this message. But in this case, we don't have anything inside this message tag. So how do we give any errors? What it does is it goes into our contact controller.java and it checks if the stuff is correct. It checks if everything is up to date and it works out. So now that you got that, let's go ahead and once again start your Glassdoor server. Click build. And once you're done with that, let's go ahead, right click and click run. What this will do is you'll find a little prompt over here that says show all contact items. Go ahead and click it and you can find that there's no contact items found. You can go ahead and create your own new contact. Let's go ahead, put Viprav, let's say my birthday over here, and let's put our phone number, which is this. If we try to save that, this will give an error because this is a string, this is not a date, but let's go ahead and try to save it. It says that it cannot be understood as a date. The example is shown over here, so let's go ahead, try to put something like 10/05/2020, right? If we go ahead and try to save that, it will give us an error called must be a past date. Remember the past annotation? It's because it's telling us that this date hasn't happened already, so that's why you can't put it. Let's put 2003 and let's try to save it. And now it's saved successfully as a contact. If we go to show all contact items, you can see that our contact is saved and you can create as many contacts as you want. If you go back to your index and show all contact items, you can see that it's still there. It's still here, and you can go ahead and click view, edit, or destroy it. And that's it. That's all there is about our address book example. And that's it. That's all there is about Java persistence APIs. Now, I think you can understand how incredible Java persistence APIs are, especially compared to other methods like JDBC, which is it's terrible. But in the next chapter, we'll be talking about more about these persistence stuff, and I will be looking forward to seeing you in the next tutorial.